We are looking at trigonometric functions. We've looked at them with acute angles and using ratios of sides of a triangle. Now we're going to get into looking at trigonometric functions of all angles. And we're going to use these special angles called reference angles to help us find these angles. And so in front of you right now are our objectives of this video. We are going to, and I've already kind of stated this in words before reading through, but let me just read through it really quickly. We're going to find the exact values of trigonometric functions of any angle. We're going to use coterminal angles to find the exact value of trigonometric functions. So if you recall, coterminal angles, those were angles that had the same terminal side. And so if we rotated maybe 45 degrees, there's multiple places or multiple angles, infinite number of angles that would get us to this 45 degrees. We could do one full rotation from 45 degrees and that would get us the same terminal side. Or we could do k times 360 degrees where k is an integer plus 45 degrees to get us there also. So those were our coterminal angles that we looked at before. We're going to look at determining the signs of trigonometric functions of an angle in a given quadrant. So depending on what quadrant our angle falls in, depends on if our trigonometric function is going to be positive or negative. We're going to find the reference angle of an angle. We're going to use a reference angle to find the exact value of a trigonometric function. And we're going to find the exact values of a trigonometric function of an angle, given information about those functions. So again, we have looked at the ratio of sides of a triangle, right triangle, to get our trigonometric functions at certain angles. So we're going to look at this almost exactly the same definition that we had before, but a little different. So let me go through and let's talk about this. And so here we have, let theta be any angle in standard position, and AB denotes the coordinates of any point except the origin 0, 0, 0 on the terminal side of theta. If r is equal to the square root of a squared plus b squared, denotes the distance from 0, 0, the origin to AB, then the 6 trigonometric functions of theta are defined as the ratios as follows. So we'll talk about the ratios in a second, but they're right in front of you. And we need to say that provided that no denominator equals 0. If we get a denominator equals 0, that trigonometric function of the angle is not defined. We will say it's undefined. We can't divide by 0. So what is in front of us is exactly what we've been doing before. It's just written a little differently. So let's look at a point. So let's say that we have some point here, AB, and it doesn't matter where we put it, except again at 0, 0. So let's just get some arbitrary point here where this is our x value A, and this is our y value B. And so we have this point here, AB. This could have fallen in any quadrant, and I just chose for now quadrant 1. Well, if we look at this and this line here, it's telling us that we can find that distance by using either the distance formula or think of it as we can make this as a right triangle with that angle that we just had, theta. And now if we make this a right triangle from that angle theta, we can figure out our trigonometric functions. So notice that our y value, which is b, that's opposite side of theta. And we had looked at finding this radius or hypotenuse before, and we had saw that we can use the Pythagorean Theorem. And so in this case, they used r. And so we know that r squared, again, is equal to a squared plus b squared. We're talking about distance, so when we take the square root, we're just looking at the positive. And our adjacent side of theta, that's just the length of x, which is, in this case, a. So it doesn't matter how big this triangle is, because of similar triangles. So let's say that maybe we extended R out further. Maybe our point was here. And we extended this out further. Maybe you call this A sub 1, B sub 1, just to denote that it could be different than what we had, which in my picture it is, before AB. This would give us the same trigonometric functions if we let R be what I just did in the green color of the hypotenuse. This is our length B, which is still opposite B sub 1. And this is our length of adjacent, which is A sub 1 in this case. So it doesn't matter how far our R value, our point is from the origin, we're still going to get those same trigonometric functions. Got those angles. And so recall we used Sohcahtoa. This was a way that you could remember the ratio of sides for sine, cosine, and tangent. Sine is opposite over hypotenuse. So if you look at this on our angle theta here, opposite is our side B. Looking at the smaller triangle, so I'm going to get rid of the bigger triangle now. So opposite is our side B, all over the radius. Or I keep on saying radius because we're going to be talking about unit circles later on in the next section, but R, which is our hypotenuse. Cosine theta is adjacent over hypotenuse. So adjacent is side A, all over hypotenuse, which is R. So it continues to be the same thing that we had before. And so tangent theta opposite over adjacent is B over A in this instance. Cosecant, which we know is the reciprocal of sine, would be the hypotenuse R over opposite, which is B. Secant, reciprocal of cosine theta is R over A, and cotangent theta is A over B, the reciprocal of tangent theta. Okay, so knowing that, we can figure out what trigonometric functions are at some particular point, given that we can find that theta. So let's just talk about this a little bit for a second, about our quadrants and our signs of our trigonometric functions and our quadrants. So recall that when you have your XY plane, we have our quadrant 1 is this upper right-hand quadrant. If we're talking about our points there, our points are, our X value is positive in this case, and our Y value is also positive. Going counterclockwise, we have our second quadrant. In this value, the X value is a negative number, and the Y value is a positive number. The lower left-hand corner, we have our third quadrant. In this quadrant, we have X is negative and Y is negative. And then the lower right-hand corner, we have our fourth quadrant, where our X value is positive and our Y value is negative. So we had just saw that these were a ratio of sides of our R value and A and B, which were our X and our Y value of our point. And so if that's the case, then in our first quadrant, well, first of all, our point, both X and Y are positive. So all of the trigonometric functions, ratio of a positive divided by a positive is positive. All our trigonometric functions in this first quadrant are positive. So all trig functions are positive in quadrant 1. But if we look in our second quadrant, notice that our Y value in this quadrant is positive, but our X value is negative. And so if you looked back over here, our A value when I pull up the ratio of sides, our A value is our X. So anything that has A in that ratio, that's a negative number. And so we have a negative number over either R, which is positive, or under B, or over B, which is also positive because that's our Y value. And so a negative divided by a positive, or positive divided by a negative, is negative. And so if you notice the ones that just have the Y in there, so sine of B over R, I'm going to just put the ones that are positive in the quadrants, but we can denote which ones are negative by the ones that aren't there. And so in our second quadrant, sine, the reciprocal of sine, cosecant, and that's it. Yeah, so sine and cosecant of theta are positive if we're in quadrant 2. If we move down to quadrant 3, we had stated that both X and Y are negative. And so if we think about ratio of sides, again, this was our point AB. So if they both have A and B in that ratio, a negative divided by a negative is positive. And so the only ones that have both A and B in here are our tangent and our cotangent. So down here in the third quadrant, the only trigonometric functions that are positive are tangent and cotangent. If theta is positive, or are positive. And so we can do that same sort of reasoning down in this fourth quadrant. Our fourth quadrant, we know our X value is positive and our Y value is negative. And so in this case, any ratio that has our X value, which was A, divided by R, or R divided by A, those are going to be the ones that are positive. And so the only ones that have A and R in them are cosine theta and secant theta. So just like Sohcahtoa is a way that we can remember the ratio of sides of a right triangle for our trigonometric functions, there's a saying here that might help you remember which ones are positive in which quadrant. To me, I just think about this as the ratio of sides, and positive and negative. If the ratio, is that going to give me back a positive or not? But there is a saying that could also help you, which is all students take calculus. So A stands for all trigonometric functions, and we're in quadrant 1. We always, for positive, we're going counterclockwise. So the second quadrant is S, that stands for sine. Sine, or the reciprocal sine, that is positive in quadrant 2. T, take, stands for tangent, or the reciprocal of tangent, which is cotangent. That one's positive, and that's quadrant 3. And calculus, C stands for cosine, or the reciprocal of cosine, which is secant. That one's positive in quadrant 4. But just a saying that could help you memorize if it's positive or negative in that quadrant. Okay, so that being said, let's look at an example where we're given a point and we want to find the 6 trigonometric functions at that point, the angle that gets us to the distance of R. from the origin. So for example, so if we're given a point, how about let's say 1/2 and negative √3/2. And from this point, let me just read the directions so you're just familiar with the terminology. It says a point on the terminal sides of an angle theta in standard position is given. So we're given this point right in front of us, 1/2 negative √3/2. Find the exact value of each of the 6 trigonometric functions of theta. First thing I would do on these is I would plot your points. So plotting our point here, I notice that we are going to be falling in quadrant 3. Actually, no, we're going to be falling in quadrant 4. Okay, so we're going to go over 1/2, and I'm just going to estimate, and I'm just going to say this is 1/2 right here. And we're going to go down negative √3/2. And so again, this is not to scale, but I'm going to estimate this is negative √3/2. And so I get this point right here. And so to find R, we can use the formula, which said that R is equal to the square root of a squared plus b squared. So the second thing that we want to do once we plot our point, find R, the distance from the point, the distance from the origin to the point. So in our case, we get R is equal to the square root. Our x value was 1/2, so we're going to square 1/2 plus negative √3/2. That's our y value, and we're going to square that. So doing that, let's simplify this down. We have R is equal to the square root. 1/2 quantity squared is 1/2 times 1/2, which is 1/4, plus negative √3/2 quantity squared. Well, negative √3 quantity squared is 3, and 2 squared is 4. So we get positive 3/4. So R is equal to 4/4, which reduces down to 1. So the square root of 1 is 1. So we know that this value R here is 1. If we want, we can create a triangle. And we create this triangle. When you're creating the triangle, always create it with the x-axis, never with the y-axis. So we're going to create it with the x-axis, and we're going to make it so that that right triangle is an acute angle. So since the x-axis, positive x-axis, is going to make this angle here, it's going to make it it's going to make it an acute angle, less than 90 degrees. Okay, so our A value, or our opposite side, is, I'm going to say √3/2 because I'm creating a triangle. I'm going to keep it positive because distance is positive. And I have my x value here. My x value is 1/2. Okay, so looking at our trigonometric functions, we know sine theta. We have to think about in this fourth quadrant, is it positive or negative? Well, sine is negative in the fourth quadrant, so we're going to put a minus. It's the opposite of theta, which is √3/2, divided by r, which is 1. So we get negative √3/2 is sine theta. So cosine theta. Cosine, so is adjacent, which is 1/2, all over r, which is 1. And so 1/2 over 1 is 1/2. We have to think about, is cosine theta positive or negative in quadrant 4? Cosine is our x value of the point over r, so it's positive. Tangent theta, we can think of it multiple different ways. We can think of it as the ratio of sine theta over cosine theta and find it that way. Or we can think of it as opposite over adjacent. And opposite of theta is √3 over 2. And the adjacent side is 1/2 divided by 1/2. The thing is, tangent theta is negative in quadrant 4. So we need a negative here. So if we invert multiply, if we flip up our 1/2 and rewrite it as 2 over 1, we have negative √3 over 2 times 2 over 1. 2's cancel, and we're just left with negative √3. So now we can get the reciprocal functions. So the reciprocal function of sine theta, that one is the cosecant theta. So reciprocal of negative √3 over 2 is negative 2 over √3. We want to rationalize our denominator. Do that by multiplying by our fancy one, √3 over √3. And we get that cosecant theta is equal to negative 2 √3 over 3. Reciprocal of sine theta is secant theta. Reciprocal of 1/2 is just 2. And then cotangent theta. Reciprocal of negative √3 is negative 1 over √3, which if we multiply by our fancy one, √3 over √3, we can rationalize that denominator, and we get that cotangent theta is negative √3 over 3. So we have now our 6 trigonometric functions of the angle from that point in the terminal side are So I had started writing out the steps, but I stopped. So let's just finish writing those out. And so first thing that we did when we were doing this problem was we plotted our point. We figured out what the distance, that side of our hypotenuse, once we form that right triangle, are, the distance from the point to the origin. So third, let's create a right triangle. With the x-axis. We're going to determine if the trigonometric function, I'm just going to say trig function, is positive or negative. In the quadrant, the point falls. And then fifth, we're going to find the ratio of sides of the triangle we created and our angle theta. So find the values of the trigonometric functions. at theta using the ratio of sides of the triangle we created. Okay. So this is when we're following, our point is following in a quadrant. If it doesn't fall on a quadrant, it's either falling on the x-axis or the y-axis. Recall that those angles that fell on the x-axis or the y-axis, we call those quadrantal angles. And in a moment, we'll look at what would happen if we had our angle theta be a quadrantal angle. But before we do that, maybe we should look at one more example. Given a point, we want to find the exact value of each of the 6 trigonometric functions of theta from that point. So let's say we're given the point this time is -1, -2. So first we're going to plot our point. And so -1 going over to the left 1, and we're going to go down 2. So we're falling in quadrant 3. We're going to create the line between 0, 0 and that point. So this would be theta, but we're going to narrow this down so that we have a right triangle. Always forming it with the x-axis. And so since we're in the third quadrant, if we're in the third or second quadrant, we form it with a negative x-axis. If we had fallen in the first or fourth quadrant, it would be with a positive x-axis. The length of our triangle, my adjacent side to this theta in here now, adjacent side is length 1, the opposite side is length 2, and we can figure out what the hypotenuses are by looking at the square root of 1 squared plus 2 squared. So 1 plus 4, this gives me r is √5. So now we can look at the ratio of sides. And while we're doing that, let's determine if our trigonometric function is positive or negative when we're in that quadrant. So we're in quadrant 3. Only tangent and cotangent is positive there. So sine theta and cosine theta is negative, tangent is positive. And so sine is opposite, which is 2 over hypotenuse, which is √5. So this is 2 over √5. Rationalizing the denominator, we get -2 √5 over 5. Cosine theta, that's adjacent over hypotenuse. So this is -1 over √5. Rationalizing the denominator, multiplying top and bottom, numerator denominator by √5, we get -√5 over 5. Tangent theta, opposite over adjacent. So opposite is 2 over adjacent, which is 1. So we get 2 over 1, or just 2. Reciprocal functions. So cosecant theta. This one's negative also. Reciprocal of 2 over √5 is √5 over 2. So -√5 over 2 is secant theta. Cosecant theta. Secant theta is going to give us -√5. And cotangent theta, this is +1/2. So we found our 6 trigonometric functions at that point, -1, -2 at theta. So let's look at what would happen. What happens if our point is on the x-axis and the y-axis, positive or negative? So if our point was a quadrantal, gave us a quadrantal angle, let's just start with the x-axis. So if we had a point on the positive x-axis, I know that my y value is 0, so let's just call this a 0. If we had talked about r was equal to the square root of a squared plus, in this case, 0 squared. So r in this case is just a. So if we think about the ratio of sides here, of how they were talking, or just the ratios. So cosine theta, this was a over r. Well, this is a over a, which is 1. Sine theta, this is equal to b. B is 0 here, all over r, which is also a. So 0 over a is 0. Tangent theta, this was b over a, or the reciprocal of this over here, which is a over 0. Can't divide by 0, so this one is undefined. The reciprocal function of cosine, that one is secant. So secant theta, 1 over 1, or flipping a over a, we still get 1. If we look at cosecant theta, though, taking the reciprocal of 0 over a, we're now dividing by 0. So cosecant theta on the positive x-axis is undefined. If we look at cotangent theta, flipping a over 0, we get 0 over a. That one's okay, because we're saying that a is not 0. And then this one is equal to 0. So notice if we're on the positive x-axis, our values here for theta that could be 0. We could do a full rotation, which would get us 360 degrees. Or we could do multiple full rotations, 360 degrees times k, where k is an integer. So that funky kind of E means contained, or contained in the set. This funky kind of Z, it means integer. And so recall integers are numbers coming in from negative infinity, dot, 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 -3, -2, -1, 0, 1, 2, dot, dot, dot. We also need to think about these because we're going to be using radians a lot, not just degrees. So theta in this case could have been 0 radians, 2 pi radians, or any multiple of 2 pi times some integer. Okay, so that's if we're on the positive x-axis. Maybe we should just go over to the negative x-axis now. If we went to the negative x-axis, this time our theta could be if we're going from standard position, that would be 180 degrees, or 180 degrees plus 360. Full rotation from 180 degrees, or we can do multiple rotations. So 180 degrees plus 360 degrees times k. But if we're talking about radians, remember the negative x-axis, that would be pi, or pi plus full rotation is 2 pi times k. So the only difference in this case is that our a value, this point here, would be negative. I'm going to say negative a. Our y value is still 0. And so cosine theta, this is equal to negative a all over r. But if we changed r, we're taking negative a quantity squared plus 0 squared. And so in this case, r is the same value. R is equal to, because negative a quantity squared is a squared. So the square root of a squared is just a. So negative a over a, so this is 1. Negative 1. Sine theta, so 0 over a is 0. Tangent theta, so we're going to have, sorry, I was off on something over here. So I'm stopping, sorry about this, but tangent theta and cotangent theta are totally, they're off. And let me just show you why. If we were looking at it as sine over cosine, 0 over a divided by 1, which is 0. So this one is 0. Cotangent theta, this is the undefined. So, and I just noticed that when I did the negative x-axis. So tangent theta, this is 0 over a, which is 0. If we look at reciprocal of cosine theta, that's secant theta. This is equal to negative 1. Cosecant theta, reciprocal of 0 is undefined. And cotangent theta, this is also undefined. So we can do the same thing, the quadrantal angles that fall on the y-axis with what we just did here with the x-axis, positive and negative. So if we look at some point on the positive y-axis first. So from standard position, theta in our case here, this is 90 degrees, or any 90 degrees plus 360 degree K. Or if we thought about this in radians, we have pi halves. And pi halves plus 2 pi times K, where K is an integer. So this point here, our x value is 0. Let's say our y value is some value b. So we have this line in here. So if we looked at cosine theta, this was our x value, which is 0, over, to figure out what r is here, r is equal to the square root of 0 squared plus b squared. What's r is equal to b. So this is over b, which is 0. Sine theta, this was our y value, which is b, over r, which is b. So this is 1. Tangent theta, this is cosine over sine. I'm sorry, tangent theta is not cosine over sine. It's sine over cosine, which is 1 over 0, which is undefined. Reciprocal function of cosine theta is secant theta, can't divide by 0. So secant theta, this is undefined. Cosecant theta is 1. And cotangent theta, that's the cosine over sine. Well, cosine, which is 0 over 1, is 0. Do the exact same thing now, though, but with the y-axis negative. So let's say we had some point here, and this point, again, x is 0. Our y value, let's say this is negative b. So if you use your formula to find r, you'll see that this is equal to b. Our theta value, if we loop around to the negative y-axis, that value of theta is 270 degrees, or 270 degrees plus 360K. Or if we were thinking of radians, that was the 3 pi halves, or 3 pi halves plus 2 pi k. So going through and doing those ratios, we get cosine theta. This is equal to the x value, which is 0, over r, which is b. So 0 over b is 0. Sine theta, though, this is our y value, which is negative b, all over our r value, which is b. So this is negative 1. Tangent theta, negative 1 over 0 is undefined. Looking at the reciprocal of cosine theta, we have secant theta. So this is undefined. Cosecant theta, reciprocal of negative 1 is negative 1. And cotangent theta, cosine over sine, 0 over negative 1 is 0. Okay, so that's what's happening at those quadrantal angles. And so those are ones that you should have memorized. So now we're going to look at reference angles. We're going to use these reference angles to help us figure out what our trigonometric functions are. So let's say that we have theta, and theta lies in some quadrant. So not a quadrantal angle, it has to lie in some quadrant. The reference angle is some value theta. So let theta be an angle, or the terminal side falls in a quadrant, falls in one of the quadrants. The reference angle, and so different books or people will call it different things or denote it different things. You might see it as theta subprime, where you have a prime there. I tend to, just so I know, and that's harder to see, I tend to put a little subscript here of r. So let me just do it that way. So the reference angle, I'm going to call it theta sub r, is an acute angle. So it means it's an angle between 0 and 90 degrees, not including 0 and 90. So it's an acute angle formed with the terminal side of theta and the x-axis. Okay, so if we fall in the first quadrant and theta's between 0 and 90 degrees, that's what we're going to use. We're just going to use theta. If for some reason we fall in the first quadrant, but So let's say this was the terminal side of theta, but let's say we do a rotation. Then we would look at this angle being the acute form, that coterminal angle that would give us that same side. So we would have this to be theta here. But if we fall in the second quadrant, so somehow our terminal side here is in the second quadrant, and this is theta. To figure out what our reference angle is, so we're forming the terminal side with the x-axis, which makes it acute. So I wouldn't want what theta is because that's bigger than 90 degrees. And so theta, my reference angle here, is forming with the terminal side and the negative x-axis. So how could we figure out what theta sub r is? Well, a full or horizontal line here, this is 180 degrees or pi. So we can look at this as 180 degrees minus what theta is. So if we subtracted off what theta was, that would just give us what theta sub r is. Let me put that back. So 180 degrees minus theta is going to give us our reference angle there. Or if we're in terms of radians, 180 degrees, that was pi radians. So pi minus theta. So that's if we're in quadrant 2. If our terminal side fell in quadrant 3, let's talk about that for a second. So if we fall into quadrant 3, so this is theta, which gets us into the terminal side in quadrant 3. So we want to figure out what our reference angle is. And so our reference angle is going to form with the terminal side and again, the negative x-axis to make that an acute angle. So if we take this whole angle that would get us to this terminal side minus this angle here of 180 degrees, if we subtract off that 180 degrees, we would get that little piece that we want. And so theta sub r this is equal to theta minus, in this case, 180 degrees, or theta minus pi. So that's if we're in quadrant 3. And the last example, we fall in quadrant 4. So if our angle theta gave us the terminal side of our angle in quadrant 4, well, if we did a full rotation, that's 360 degrees. So if we did a full rotation and then we subtracted off what theta was, that would give us our reference angle, which is that angle that is formed between the terminal side and the positive x-axis. Theta sub r. We can find that by doing the full rotation minus, so 360 degrees minus what theta is. Or in radians, that would be 2 pi minus theta. Okay, so these are our reference angles. And so we can look at finding the following. So technically, our trigonometric functions, cosine of theta, this is equal to either positive or negative, depending on what quadrant we're in, of cosine of theta sub r. So that is true for all of our trigonometric functions. So sine theta is the same thing as plus or minus sine of theta sub r. Tangent theta is equal to plus or minus tangent of our reference angle, theta sub r. Cosecant theta, same thing. It's either positive or negative, depending on which quadrant we're following. Cosecant theta sub r, secant theta equals plus or minus secant theta sub r. And cotangent theta is equal to plus or minus cotangent of our reference angle, theta sub r. So that's where it's really important to figure out what sine is our trigonometric function in that quadrant. And then we're going to be using these reference angles to help us evaluate the trigonometric functions at an acute angle. Let's look at an example of this, and then we'll take a break. Pulling up an example. Actually, before we look at our trigonometric functions, let's just look at finding the reference angle, and then we'll look at, when we get back from the break, evaluating the trigonometric functions there. So if you wanted to figure out, find the reference angle of each angle. So that's our direction. So find the reference angle. Each angle given. So let's say we had 210 degrees. So first thing I would do when they gave this to me is I would first draw my angle. So 210 degrees, this is 180 degrees. Think to myself, how many more degrees do I need to go up to get to 210? And so 180 plus 30 degrees would give me up to 210. And so in here, this is 30 degrees. So our reference angle, theta sub r, this is equal to 30 degrees. So I'm going to pause here. Okay, we have another example in front of us. We're given 19 pi 6, and we want to find the reference angle to that given angle. So first thing we want to do is we want to graph 19 pi 6. So graphing that angle, I know I'm going counterclockwise because my angle is positive. First thing I would do is I would see how many times does 6 go into 19. And so I know that 6 times 3 is 19. And so I can think of this as, this is the same thing as 3 pi plus I would have, that would give me 18 pi, and I would have one more pi 6 left. So that kind of helps me kind of figure out how I would write this. And so if I'm starting on the standard position, going counterclockwise, 3 pi first. And so here's pi, full rotation is 2 pi, and then we have 3 pi, and then adding pi 6 to that 3 pi. That's about right here. So this right here is 19 pi 6. And my reference angle is forming between this terminal side and the x-axis. And because I'm in quadrant 3, I could get this by seeing what I was adding to get from that pi to this angle, which would be pi 6. So my reference angle is pi 6. The problem here, if I was to look at this and I would subtract off pi from this, so remember we said if it was in quadrant 3, we could look at what our angle was that gave us that terminal side, and we could subtract off pi. The problem if I did that, so 19 pi 6 minus pi, here when I got a common denominator, so pi is the same thing as 6 pi 6, this would give me 13 pi 6. So you would have to continue to do this until you got to an acute angle. I know this is not acute. And so I would, again, then subtract off pi from here. So minus pi, so 6 pi 6. This would give me 7 pi 6. If I subtract off another pi, which I could write as 6 pi 6, this would get me back, this would give me this would get me pi 6, which I now know is an acute angle, which is less than 90 degrees. So if you had more than one rotation, if it made a full rotation around the circle, then you're going to have to keep on subtracting until you get to an acute angle. Okay, so let's look, actually, let's look at one more. So let's say you are given negative 5 pi 7s. Okay, so we want to draw this. I know that we want to draw this. It's going to be going clockwise because my angle is negative. If it helps you, then convert this into degrees. And recall, to rewrite it into degrees, we would multiply this by 180 degrees divided by pi. So pi's are going to cancel. 7 goes into 180. Don't think it goes in easily. I don't have my calculator in front of me, so let's just do it. That goes twice, that's 14, this is 40. So this goes in 5 times. So that's 35, this is 5. So let's just get an approximation really quickly, just so I know what quadrant I'm in. So pulling up the calculator, we convert this to degrees. This is approximately negative 128.6 degrees. So that helps me kind of figure out what quadrant I'm in. And so I can tell that I'm in quadrant 3 because I'm going clockwise. This is negative 90 degrees. And then I need 38 more degrees, 38.6 right in here. So this is negative. I'm going to keep it in terms of radians though. So this is negative 5 pi 7s. Okay, so we need to figure out how much more this angle needs to be right in here. This is theta sub r, forming with a negative x-axis. And I know that this right here, let's just think about this for a second with positive angles. So if this is pi minus this 5 pi 7s. We're getting a common denominator is 7. So I can rewrite this pi as 7 pi sevenths. This would give us back 2 pi sevenths. Our reference angles are always positive angles. And so that angle that would get us up to this from the negative x-axis down to our terminal side would be 2 pi sevenths. Okay, so let's jump into the trigonometric functions. So evaluating trigonometric functions using reference angle. So pretty much our trigonometric function at our angle theta is going to equal positive or negative of the trigonometric function at our reference angle. And so first thing you want to do when you're trying to evaluate these trigonometric functions is we want to draw our angle and find our reference angle. So if we wanted to evaluate, and you would be doing this without a calculator. So if we wanted to evaluate, let's say, cosine of 600 degrees. So first thing we want to do is we want to draw our angle of 600 degrees. It's more than 360, so I know we're doing at least one full revolution. So one full revolution gives me 360 plus 9d, that is 450. 450 plus 9d is 530. 530 up to 600. 530 up to 600 is 70 degrees. I think I'm off somehow. So let me just, because it's without a calculator and I know that, so 600, let's do minus 360. That gives me 240 degrees. Okay, so our coterminal angle to 600 degrees is 240 degrees. So 240 degrees, this right in here is 60 degrees. It's 180 minus 240, or 240 minus 180 is 60. So we found what our reference angle is. Our reference angle is 60 degrees. So these are the ones that we should know, 30, 45, 60, and our quadrantal angles. And so cosine of 60 degrees, I know is 1/2. We looked at our fingers before. Cosine started on top. And so counting the fingers down to that angle for cosine, it's one finger to get down to 60 degrees. So that's root number of fingers. So root 1 all over 2, which is 1/2. But cosine is negative in quadrant 3. So this is equal to negative of cosine of 60 degrees. So this is equal to negative 1/2. So let's look at another one. So let's say they wanted us to find sine of negative 2 pi thirds. So first step, graph your angle. So graphing negative 2 pi thirds, I know I'm going clockwise. I know if I added a pi thirds to the 2 pi thirds, that's 3 pi thirds. That would get me up to pi. So negative 2 pi thirds is right here about. So our reference angle again is forming with the negative x-axis. So pi minus 2 pi thirds gives me pi thirds. And so my angle here is equal to pi thirds. So this is equal to, and we have to determine is sine positive or negative in quadrant 3. So sometimes it's helpful to say, okay, this angle here is in quadrant 3, my reference angle. And so this is equal to negative of sine of pi thirds. And so this one is negative sine of pi thirds is root 3 over 2. So this is negative root 3 over 2. So if we were looking at tangent of 8 pi thirds, so we want to first graph 8 pi thirds. Well, I notice that 3 goes into 8 2 times. So this is the same thing as 2 pi plus, we need to go another, we'd have a remainder of 2. So this would be 2 pi plus 2 pi thirds. So if we went 2 pi plus 2 pi thirds, that would get us up here in the second quadrant. So this is actually 8 pi thirds. So our reference angle, again, is forming with the terminal side and the negative x-axis in this case. And so we have theta sub r. So thinking of how much more I need to get up from 2 pi thirds to pi, I need another pi thirds. And so my theta sub r is pi thirds. So this is tangent. We can either look at this. Tangent in the second quadrant is negative. So we have tangent of 8 pi thirds. This is equal to negative tangent of pi thirds. If you didn't have that one memorized, you can put it sine over cosine. So this is negative sine of pi thirds over cosine of pi thirds. Sine of pi thirds is the root 3 over 2, all over cosine of pi thirds, which is 1/2. So invert multiply, and this would give us negative root 3. So tangent of 8 pi thirds is negative root 3. So the next example in front of us is cosine theta equals negative 1/3. We're given that theta falls between 180 degrees and 270 degrees. And it asks us to find the exact value of each of the remaining trigonometric functions of theta. So that's going to help us because we know which quadrant we're in. Theta is contained between 180 degrees and 270. We know that our angle is contained in quadrant 3. So this is going to help us when we're looking at, is our trigonometric function positive or negative? So when I'm doing these, I kind of ignore my sine and I create my triangle. And so I know that if I had a right triangle and I put theta here, and I know cosine is adjacent over hypotenuse, so I would know adjacent side of my theta would be down here, 1, hypotenuse would be 3. And so I could find my remaining side by using the Pythagorean theorem. So let's say that this was b. So I know that 3 squared is equal to 1 squared plus b squared. 9 is equal to 1 plus b squared. Subtract 1, get b squared equals 8. So b is equal to the square root of 8. And you can pull out a piece there. That's 4 times 2. So square root of 4 is 2. So b is equal to 2 root 2. So knowing that, I can now use my ratio sides of the right triangle for theta to figure out my remaining trigonometric functions, and then just be cautious of which quadrant I'm in and if the trigonometric function is positive or negative. So sine theta, I know it's negative in quadrant 3. So this is equal to negative. Now looking at the ratio of sides, sine is opposite. So this is 2 root 2 all over hypotenuse, which is 3. So we get negative 2 root 2 over 3. Tangent theta, I'm in quadrant 3. I know tangent theta is positive. And so opposite of theta is 2 root 2 all over the adjacent side, which is 1. So looking at my reciprocal functions, reciprocal of cosine theta is secant theta. So secant theta, reciprocal of negative 1/3 is negative 3. Cosecant theta, which is a reciprocal of sine theta, that's going to give me negative 3 all divided by 2 root 2, getting a common denominator, or not a common denominator, getting rid of the radical in my denominator. Multiply by fancy 1, root 2 over root 2, and I would get back negative 3 root 2 all over. Root 2 times root 2 is root 2 squared, or 2. So that's 2 times the 2 out front here, so that would give me back 4. So that was cosecant theta. Cotangent theta, reciprocal of tangent. It's a tangent, so I wrote it cotangent. So this would be positive 1 all divided by 2 over root 2, rationalizing my denominator. So I get cotangent theta. This is equal to root 2 all over, again, root 2 times root 2 is 2. 2 times this 2 over here is 4. So doing the same exact thing, but this time, let's say you're given that cosine theta, this is equal to negative 1/4. And we're given that tangent theta is greater than 0. So by that information, you should be able to deduce which quadrant theta falls in. Well, tangent theta is positive in 2 quadrants. Tangent theta is positive in the first quadrant. All of our trigonometric functions are positive in the first quadrant, but it's also positive in the third quadrant. So cosine theta is a negative value, and so it can't be in the first quadrant. It would have to be in the third quadrant. So we know that theta, again, in this case, example, is in quadrant 3. And so based off of that, we know which trigonometric functions are positive and which are negative. Again, I would ignore my signs and I would create a triangle using the information that theta, cosine is adjacent over hypotenuse. So length here, the adjacent side is 1, hypotenuse is 4. So we can figure out the opposite side, let's call it b, by using the Pythagorean theorem. 4 squared is equal to 1 squared plus b squared. So we have 16 is 4 squared. So 16 equals 1 plus b squared. Subtracting 1, we get b squared is equal to 15, or b is equal to root 15. So sine theta is negative because we're in quadrant 3, and it's adjacent, not adjacent, opposite, which is root 15, all over hypotenuse, which is 4. Tangent theta, we're given was positive. We're in quadrant 3, which is positive. Opposite over adjacent, so we have 1 over root 15. Rationalizing the denominator, we get root 15 all over 15. So looking at our reciprocal functions, cosine theta was negative 1/4. So that tells me that secant theta is the reciprocal of that, so negative 4. Cosecant theta is a reciprocal of sine theta. So this is negative 4 over square root of 15. Rationalizing the denominator, multiplying by root 15 over root 15, we get negative 4 root 15 divided by 15. Cotangent theta is the reciprocal of tangent theta. I'm going to look at the reciprocal before I had rationalized the denominator. So this is just going to be positive root 15. So given one trigonometric function, information about theta can help us decide which quadrant we're in, and then we can find the remaining trigonometric functions. So if it gives us one that is not cosine or sine or tangent, we can still figure it out. So for instance, if we're given that cotangent theta is negative 2, and we're given that secant theta is greater than 0. So for me, it would help me if I, at least for the secant theta, I rewrote that in terms of sine and cosine. So secant theta, I know, is 1 over cosine theta. So I know 1 over cosine theta is greater than 0. So that tells me that cosine theta has to be greater than 0. And cosine theta is greater than 0 in quadrant 1 and quadrant 4. But my cotangent is negative. So I know then that it can't be quadrant 1 because all my trigonometric functions are positive there. So I can tell that my theta value is falling in quadrant 4. So theta is contained in quadrant 4. So this is going to help me determine if my trigonometric functions are positive or negative there. I know that it's reciprocal of tangent theta, tangent, Sohcahtoa, opposite over adjacent. So I know that cotangent theta is adjacent over opposite. So now I can form my triangle. And if it's a whole number, we can always put it over 1. I'm going to ignore my signs. And so adjacent side would be 2. Opposite side is 1. So I need to figure out what my hypotenuse is. So let's just call it C. So we know C squared equals 4 squared plus 1 squared. So C squared is equal to 16 plus 1. So C is equal to the square root of 17. So now using that, I can figure out what the rest of my trigonometric functions are. So cosine theta, just looking off of my triangle, I know is positive because theta is in quadrant 4. Adjacent is 2 all over the reciprocal, not reciprocal, all over the hypotenuse, which is root 7. And so rationalizing my denominator, I get cosine theta is positive 2 root 17 all over 17. Sine theta, it's negative in quadrant 4, and that's adjacent side. No, it's not. I keep saying that. It's opposite side all over hypotenuse, which is root 17. Rationalizing our denominator, we get sine theta is equal to negative root 17 all over 17. Reciprocal functions, cotangent theta, so tangent theta reciprocal of negative 2 over 1 is negative 1/2. Secant theta, reciprocal of cosine theta, this is root 17 over 2, positive. And cosecant theta, which is the reciprocal of sine theta, looking at it before I rationalize the denominator, flipping it, I get negative root 17. And based off of the trigonometric function it gave me and which trigonometric function was positive, I could determine which quadrant I was in and then the signs of the other trigonometric functions and created a triangle. So looking at another example, we're given functions. So we're given that the function f of x, little f of x, is equal to the trigonometric function sine x. Capital G of x is equal to secant of x. And capital F of x is equal to cosecant of x. So part A wanted us to find what f of 7 pi fourths was, and then what is the point on the graph of f. Okay, so looking at this, first thing, 7 pi fourths, f of 7 pi fourths. So this is telling me to go into my function little f of x and plug in 7 pi fourths wherever I see an x. So f of 7 pi fourths, this is equal to sine of 7 pi fourths. So first thing I want to do is I want to graph 7 pi fourths. Okay, so let's just count by pi fourths. So pi fourths, this would be halfway between the x-axis and the y-axis, positive. So this is pi halves, or 2 pi fourths, 3 pi fourths, 4 pi fourths, 5 pi fourths, 6 pi fourths, 7 pi fourths would get me right here. So I can see that we're in quadrant. This is contained in quadrant 4. And I can determine what my reference angle is. So this theta right here, theta sub r, well, I would need one more pi fourths to get me up to 8 pi fourths, which is 2 pi. So we can evaluate sine of 7 pi fourths by determining is sine positive or negative in quadrant 4. Well, cosine and secant are positive in quadrant 4, so that means sine is negative. So this is equal to negative of sine of pi fourths. So this is equal to negative root 2 over 2. Okay, so that was the first part. And then it wanted to know what is the point on the graph of f. So how can we figure out what that point is? Well, we could, if we wanted to, we could create a triangle. And so let's create a triangle really quickly. This was theta. And so let's ignore the signs. Opposite over hypotenuse. So opposite is root 2 all over hypotenuse, which is 2. So let's figure out what this side is right here. And so maybe let's just call it x. So we know that 2 squared, the hypotenuse squared, is equal to x squared plus root 2 squared. So we have 4 is equal to x squared plus 2. Subtract 2, we get, on both sides, we get 2 is equal to x squared. So x is equal to root 2. So let's think about this for a second. And our x value in quadrant 4 is positive. So this x value would be this piece right in here is positive, and our y value, getting us down here, is negative. And so our point is going to be root 2, and then y is negative root 2. So we found our point that would be on that function of f. And we found our value of f of 7 pi fourths. Which was negative root 2 over 2. Okay, so we're about out of time. So I was going to find g, capital G of 7 pi fourths, and capital F of negative 225 degrees. So that actually would be a great place to stop and for you guys to do a try it. So for the try it for today, let's do the following. So given these values in here, f of x is sine x, capital G of x is secant x, capital H, f of x is cosecant x. Let's just call it A for you. Find capital G of 7 pi fourths. What is a point on the graph of G? And then part B, find capital F of negative 225 degrees. And then what is a point on capital F? Okay, so go ahead and try those. I'll have a place on Canvas for you to upload those try-its for this week, for this today.